Hello, all of you. Now, today we are starting a new chapter, and that is acoustics. Acoustics is a branch of physics which help us to analyze the effect of sound in us. Just like if we are preparing a musical device, a earphone, that means what should be its intensity so that we can listen the sound properly, but it will not damage our ear system. If you're designing a building, the building's tolerances should be so that due to some sound or due to some vibration of earth, the building may not collapse. The same thing on the bridge also. Same thing for the devices which we are using in our house, like television set, computer systems, everything. Because that we need the sound, but that sound must not harm us. So that properties will be decided by this acoustics. So how I define acoustics? It is a branch of physics. It is the branch of physics which deals with the study of sound and its application. In class 8, we will focus to this sound only and its properties. But in high classes, as you go, then you will go for this acoustics. There are so many other things also you'll have to study. But it is the just alphabet of acoustics in class 8. Sound. So what is sound? If you are communicating with each other, if you are listening anything, or if you want to narrate something, then it's the sound only which is helping to interact with each other. It is the sound only through which we can come to know what the instruction is given to us. It is the sound only makes fresh to our brain when we are listening to the music. It is the sound only which irritates us if an unwanted sound is produced. So sound is a source of energy which gives us sensation of hearing. Sound is a source of energy which gives us sensation of hearing. It's a source of energy which gives us sensation of hearing. We can't imagine a world without sound because if we will not communicate with each other, we can't interact, we can't survive also. So, first question arises, how does the sound produce? So, sound produce due to vibration of any body. Vibration of any body. Like two words are there, the sound is getting produced. If you are not interacting, will the sound be produced? No. How we are able to speak? We are moving our tongue in such a way that whatever word we want to pronounce, that is coming out from our tongue. So the tongue is vibrating and the air column on our mouth, the air on our mouth is producing that vibration. So the sound is coming. We may increase the intensity of sound, we may decrease the intensity of sound. So it depends how we are vibrating our tongue. So vibration of anything produces sound. You can sum up it by saying that vibration of anything produce sound. Now, the next thing is there, what are the properties of sound? What are the characteristics of sound? So, you can write, please pause the video and write it down or take a screenshot of this. Properties of sound. First is sound is a mechanical wave. sound is a mechanical wave. What does it mean by mechanical waves? That means it can propagate on material medium. Material medium, solid, liquid, and gases. It can propagate in these three. That means sound can't propagate in vacuum. It will not move on vacuum. It needs material medium. Now, coming to the material medium, is the density of solid, liquid, and gases the same? No. The density of solid is higher, the density of liquid is little lesser than this, and the density of gases are very less. So, the propagation of sound, the speed of sound will be maximum on solid. It is quite less than, solid, and here it is less than solid as well as liquid. So, property of sound, that sound is a mechanical waves. It travels only on material medium. Second is sound has its own origin of direction. Suppose you take your mobile phone and play notes on it. Now you change the direction of the mobile phone. Will the intensity of sound will change to you? Of course, it will change. Why? Because sound is propagating and it will carry it in a direction parallel with respect to medium of propagation. When you are changing the direction of the mobile phone, now the sound of mobile phone is going on the back direction and you are on the opposite sides of the mobile phone. So the intensity of sound heard by you will be less than this sound, whatever it has originated. So two properties are there which you have to study now, that the sound is a mechanical waves. Sound has its own origin of direction. That means the direction on which the sound is produced, it will propagate maximum on that direction. Whether it is the air can throw it on the other side or air can throw it backward direction also. But if air will be have zero velocity, that means the air is still, air is not blowing. So on that case, the sound will travel in a direction where it is propagated. To prove it, you can take a small thread, you stretch it with two rigid support and you pluck it. Once you pluck the string and try to bring your ear near to it, you will get the maximum sound is there. As you will go a little far from it, the intensity of sound will get decreased. Why? Because you will listen. So, the two properties of sound will help us to know few other quantities in class 8. It will help us to know some type of quantities also. So let's move for those quantities. Basic terms of sound propagation. That means how the sound will propagate, it will depend upon some quantities. The first one is amplitude. The maximum displacement of a vibrating body from its mean position is termed as amplitude. Suppose you have tied a string. Now you are plucking this one. When we are plucking it, it will go to random up and down direction. So, what will there? It has gone to certain direction, suppose. So, from this position, this is the maximum displacement. This is the maximum displacement in the downward direction. So what we may conclude, this distance are amplitude. That's why if you have to call a person who is little far from us, I have to increase my sound. That please come here. That means we are increasing the amplitude. We are increasing the amplitude, the sound will cover to a long distance. So amplitude is the distance. So amplitude, SI unit of amplitude is meter. Where is the distance? Now, the next quantity what will go to the frequency. Frequency. I will define it. Number of vibration. Number of vibration. A vibrating body completes in 1 second. I will come to this diagram. If we are plucking it in any direction and it is vibrating, so first vibration is to here, to there, and finally this position. Please see again. First from here, the body has moved to there, then here, then again come to here, and finally come to there. It's one oscillation. So how much oscillation it is taking in 1 second, that is its frequency. So number of vibration, a vibrating body completes in 1 second is known as its frequency. More is the frequency, more will be the vibration. Less is the frequency, less is the vibration. So frequency with, if you denote by F, then it is 1 by T. This is the expression of frequency, and its SI unit is second inverse, because SI is the time is second and just it's the reciprocal of time, so second inverse. Or in honor of the great scientist Hertz, we have named the SI unit of frequency as Hertz. The next quantity is time period. Listen student, time and time period are two different terms. Time means span of event, and time period is how much time the body has consumed to complete its vibration. How much time the body has taken to complete its vibration. So time taken by a vibrating body to complete one oscillation is termed as time period. It is just again the reciprocal of frequency. So frequency, when we will divide by unit part, then we will get the time period. Its SI unit is SI unit of time period is second. Time period in acoustics help us to know the nature of vibration of that particle. So when we purchase a music system, first of all we see that how much power it is consuming, but what is its frequency. Because that frequency helps us that what is the nature of amplification of that musical devices. The next term is wavelength. Wavelength is the distance between two successive positions of the body during its motion. Suppose the body is curving like this. So this entire distance from here to there will be a wavelength. But if this frequency is getting divided, so we have two type of things. One is zero displacement, another is you try to have a proper diagram, and another is maximum displacement. So two positions are there, one of maximum displacement, one of minimum displacement. The distance between these two, maximum displacement or the distance between these two, minimum displacement, both are known as wavelength. Maximum to maximum, minimum to minimum, both are known as wavelength. Its SI unit of wavelength is meter. Please write down all those things in your copy and try to read it again and again. If any type of confusion will be there, feel free to WhatsApp me on my number. Thank you.